Welcome to Intro to Trig Substitution. So the general idea here is we are now going to use a special form of substitution where we substitute in a trig function instead of a u. This technique is most useful when we have a square root of something squared plus something squared, or a square root of something squared minus something squared in our integrand. So before we get into the particular substitutions that we can make, let's just do a quick review of right triangle trig and Pythagorean theorem, and you will see some of those square roots pop up. So recall, if we have a right triangle, we'll go ahead and label one angle as theta. We'll label the leg that's adjacent to that angle ADJ for adjacent. The leg opposite, we will label OPP for opposite, and then the hypotenuse, we will just label HYP for hypotenuse. Then the trig functions, our six basic trig functions, can all be written in terms of ratios of these three sides. So the six basic trig functions can be written as ratios. We have sine of theta is the opposite side over the hypotenuse. Therefore, cosecant of theta is the hypotenuse over the opposite. Cosine of theta is adjacent over hypotenuse, and therefore secant of theta is the hypotenuse over the adjacent. And finally, tangent of theta is opposite divided by adjacent, and therefore cotangent of theta is the adjacent divided by the opposite. So these were our six basic trig functions as ratios of the sides of a right triangle. Furthermore, based off the Pythagorean theorem, we have the hypotenuse squared is equal to the adjacent side squared plus the opposite side squared. Therefore, we have that the hypotenuse should be equal to the square root of the adjacent squared plus the opposite squared. We have the adjacent side should be equal to the square root of the hypotenuse squared minus the opposite squared. And the opposite should be equal to the hypotenuse square root of the hypotenuse squared minus the adjacent squared. So note, each of these square roots takes the form of the ones that I just mentioned would be useful. So just again, note, each of these takes the form square root of something squared plus or minus something else squared. And so we can now see, we can start plugging these versions of hypotenuse, adjacent, or opposite into our trig function ratios, and trig substitution will fall out of that. So if we start plugging these square root versions of hypotenuse, adjacent, and opposite into our trig function ratios, then trig substitution kind of falls out of that. So in the next video, we will look at the specific substitutions that are useful depending on the square root we have. So again, this was more the background, why we use those square roots and how we can introduce the trig functions from a right triangle. The next video, we will look at the specific substitutions that we will use.